All right, 2.2, we're going to look at operations with rational expressions, part 2. Now, when adding or subtracting rational expressions, you're to do the following. Exactly like when we were multiplying and dividing, it has the same first step. You have to factor, including common factor, when possible. Now, what's different about adding or subtracting is normally, once you factor it, you then state restrictions and you cancel. Well, here, we also state the restrictions on the denominator, but here, we're adding or subtracting. So once you state restrictions, you might need to cancel from the numerator to the denominator, but you cannot go and cross-cancel, which we'll see an example of. What else is important is that once you state restrictions and possibly cancel, you now have to, like adding or subtracting fractions, find a common denominator. Once you determine that common denominator, you must show the common denominator in factored form and then simplify the numerator. And you'll see examples of that in this section here. All right, example 1. You're asked to simplify the following. 1 over 5x plus 1 over 2x, and then you have a second one over here. So let's look at the first one. What will be the common denominator here? With 5 and 2, the common denominator will be 5x and 2x. Sorry, the common denominator, both of them have an x, so we need to have an x in our denominator. And both of these have numbers that I cannot make one into the other. So 5 and 2, the common denominator will be 10. So we want a common denominator of 10x. And now you'll notice here that I put boxes. The boxes here are your licenses. Remember, you always need a license when simplifying rational expressions, so I recommend that you write out the box like that. And what you do on the bottom is you write 10x, and on top, what you want to do is find out what the common denominator is going to be. Here, the denominator is 5x. We want it to become 10x. How are we going to do that? Well, 5x times 2. And whatever we multiply on the bottom, we have to do on the top. So we multiply by 2, both the top and the bottom, and that gives us 2. Now the next one, 2x times what gives us 10x? That is times 5. And then we multiply by 5 on the top. Once we do that, we can now say, okay, well, 1 times 5 is 5. 2 plus 5 is, all right, now wait a minute. Before we do anything else, we want to now simplify. Simplify the expression, x cannot equal 0. To simplify, x cannot equal 0, that's our license to cancel. There's nothing to cancel here, but that gives us the permission to simplify the numerator. You get 7 over 10x. Now I know some of you are going, well, the restriction didn't help us here in terms of being able to cancel anything. And you're right, it didn't. But in this case, we're not looking at canceling, we're looking at simplifying. So we want to be able to simplify. In order to simplify, we have to make sure we have our restrictions. Let's look at the next one. Looking at the denominator and looking at this denominator, we can state the restrictions right away. We can also determine the common denominator right away. Our common denominator is going to be a, because this one has an a, and although this one doesn't, we can make it become a. Both of them have a b, so we include a b, and we have to include the number 2. Now, whatever I do to the denominator, I must do to the numerator. So in this case, I'm going to multiply the denominator by 2 to get 2ab. So whatever I do to the bottom, I have to do to the top. So I multiply by 2 to the whole thing in the numerator. 2 times ab squared is 2ab squared, plus 2 times 2, which is 4. Next, we're going to multiply the second one by what will make it the common denominator, and that is the letter a. A times both the top and bottom will give us our common denominator, so it'll be a times b plus 2. A times b and a times 2, which is ab minus 2a. Now, don't forget there is a minus here. So minus ab and minus a times plus 2. That's how we got this. Now, before we simplify, state the restrictions. So our license to simplify, A cannot equal 0, B cannot equal 0, and these values are correct. Another way to write this would be to write A, comma B cannot equal 0. So it's another way to write the exact same restriction. All right, simplify the numerator. You get 2ab squared minus ab minus 2a plus 4 all over 2ab. And this will give us our final statement here. All right, moving forwards, part C. Let's go a little bit more tougher here. This time we have polynomials in the denominator. What do we do now? Well, find a common denominator, and we can even state our restrictions. We can state our restrictions because the denominators are x minus 3 and x plus 2. So our restrictions are going to be x cannot equal negative 2, x cannot equal 3. Common denominator is x minus 3 times x plus 2. And I'm not worried of when you state the restrictions, but more so that you state them at the question or just below the question. Now the numerator is going to be x plus 5 times x plus 2, because that's what's missing in this denominator to become this denominator. So x plus 5 gets multiplied by x plus 2, which is going to be x squared plus 5x plus 2x, which will give us plus 7x plus 10. Next, the second part is going to be multiplied by x minus 3. So when I multiply by x minus 3, I get x squared. And we don't have to worry about when there's a minus, we have to worry about the sign change. When it's a plus, we don't have to worry about a sign change. So we're looking at x times x, which is x squared. Now, minus 7x minus 3x is going to give us minus 10x. And minus 3 times minus 7 is plus 21. What we'll do now is collect like terms. Because we've already stated our restrictions, we have our common denominator, we can now simplify the numerator. And we get 2x squared minus 3x plus 31 with the denominator as such. Now, really important, folks, if I had something I could cancel up and down, I would cancel. The reason you must cancel early is over here you won't have something more complicated. We'll see an example of that coming up shortly. All right, another example, x plus 9 over x squared minus 2x minus 48 minus x minus 9 times x squared minus x minus 30. What's going on here? Well, we have subtraction of two rational expressions, and what we want to do here is we need to factor the denominator of both of these pieces. So we factor the denominator, and once we factor these denominators, I want you to notice that if anything could cancel, I would recommend that you cancel it right away. So do we see anything that can cancel top and bottom here? No. What about over here? No. So now you can state your restrictions. X cannot equal what values? Well, starting over here, 8 and negative 6, and 5. So let's put them in order. Negative 6, 5, and 8. In order, and you do not repeat any restriction. Now, the next step is to find the common denominator. Both of these have an x plus 6, so that has to be there. An x minus 8 and an x minus 5. So this denominator becomes this denominator. How? Well, x minus 5 is missing, so we multiply this whole rational expression by x minus 5. And when we do that, x minus 5 times x plus 9 means that you'll have x squared plus 9x minus 5x, which is plus 4x, minus 45. Next, you have a minus, and you're going to times that whole thing by something. What are you going to times it by? Well, let's multiply it by. Well, let's look at the denominator. X plus 6, x minus 5. No problem, no problem. We're missing the x minus 8. So we're going to multiply top and bottom by x minus 8. Now be careful of this minus here, folks. So I put a minus and then I put a bracket for the expansion. When I expand it, I will get x squared minus 17x plus 72. And once I do that, I can apply the negative right through and get our final answer simplified. A couple of other things to note. Not only do you not repeat restrictions, and you have to look for canceling if you can, what's important here is you don't have to necessarily expand the way I do by doing the OI quickly, the outside, inside, and combine them. You could easily take an extra step to expand it completely out. That is not a problem. All right, now expand it and collect like terms. The bottom, we leave it alone. We leave it in factored form. And on the top, we simplify it. So we have x squared minus x squared is gone. 4x plus 17x, which is 21x. And negative 45 minus 72 is negative 117. So this is the final answer to this question. All right, hopefully this is starting to make sense. We're going to go a little harder now. Each little step is getting a little bit harder each and every single time. So the next one, part E, 10x squared minus 19x plus 6 over 15x squared minus 16x plus 4 divided by 12x squared minus 16x minus 3 over 30x squared plus 5x minus 6x minus 4 over 180x cubed minus 90x squared minus 20x. Okay, folks, so this is a really big one here. And notice I have division and subtraction. Really important that this will be one of the inquiry questions you'll see on your test. The inquiry questions that are involved, we're looking at two-step process. BEDMAS is for sure one of the important processes that we'll be looking at. So you need to factor the numerator of this. What two numbers multiply to give you 60 and add to give you negative 19? Hopefully you're thinking 15 and 4. Negative 15 and negative 4. So to get 15, I have to get a 5x from the 10x squared and a 3 from the 6. A minus 3 to get that negative 15. Next, I need a 4. Well, the 10x squared, I'm going to get 2x here. And then from the 6, I'm going to get a minus 2. So that gives us our minus 4x when we do the OI. Next, the bottom. The product is 60 and the sum is negative 16. Well, that's going to be negative 10 and negative 6. So we want to find the combination of negative 10 and negative 6. Well, I have 5x over here and negative 2 over here to give us negative 10. And then 5x times 3x is going to give me 15x squared, and there's the negative 2. So the positive 4 gets negative 2 and negative 2. All right, next, the division we want to change to multiplication. If we change it right away and just remind ourselves we must state the restriction for this, 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 don't forget that also will be a denominator when we flip it over, and finally this. So we will have 4 denominators that we'll have to state restrictions for. Back to the question, this one here at the bottom, you common factor of 5x out, and that leaves us 6x plus 1. When I take out the 5x, I get 6x plus 1. From here, I'm going to get a product of negative 36 and our sum of negative 16. Well, that will be 18 and 2. Negative 18 and positive 2. So I'm going to take 6x from here and minus 3. So 6x and minus 3. From over here, I'm going to have the 2x to make 12x squared, and minus 3 and plus 1 to give us negative 3. So Now, I know some of you are tempted to cancel right away. Please don't until we finish the whole question. So, we need to common factor in the numerator of this expression, and in the denominator we're going to common factor. And once I common factor, that will allow us to factor that again. So we're going to repeat everything so that we can factor this last step. Now what you could have done was written this on the side and then factored it if you wanted. But here I'm going to just show you what step, the next step. So what will the product be? Negative 36. The sum is negative 9. So what numbers are we looking at here? Well, we're looking at 12 and 3. Negative 12 plus 3x will give us negative 9x. So x cannot equal the following values. Now let's look. We have 2/5 starting over here, 2/5, 2/3, 0, negative 1/6, 3/2, because we already have that, folks. So let's go through it again. And then again 0, which we already have, negative 1/6, which we already have, and 2/3, which we already have. So now we're going to look at these and put them in order, starting with negative 1/6. Next goes 0. Next goes 2/5. Next goes 2/3. And then finally 3/2. And that will be x cannot equal those values. All right, well, now that we've done that, we can now cancel. First of all, let's look at up and down canceling. We can cancel the 5x minus 2 with the 5x minus 2. We can cancel the 6x plus 1 with the 6x plus 1. We can also cancel 3x minus 2 with 3x minus 2. Very important that you cancel up and down first. Next, what you're going to cancel is going to cancel across only if there's multiplication, meaning that we cannot cancel anything else in this with the exception of the 2 and the 10 being canceled to give you 1 and 5. That's it. Nothing else can be canceled over here in this part. We leave it alone. In this part, we can cross-cancel because there's a product going on. There's multiplication. So, can we cross-cancel anything? Well, yes, we can. 2x minus 3 cancels with 2x minus 3. So, what are we going to be left with? Well, we're going to be left with 5 on top, because right up here I have 5 and an x, that's left on the top part of this expression, divided by 3x minus 2. Then we have a minus, and then what we're going to have here on top is a 1 over 5 times 5x times 6x plus 1. So this is our expression simplified, but not fully simplified. Next step is to find a common denominator. So we take the same thing, and now we find the common denominator. Now rewrite the question, as you can see here, and we're going to find the common denominator. The common denominator is going to be, that is from the previous question, it's continued. Okay, the following expression. Ready? Here we go. Common denominator is going to be 3x minus 2 times 5x times 6x plus 1. And we just put it in order. Now that's a lot of steps there, folks. I'm going to rewind a little bit. So, again, you see, this is the denominator. I just took the denominator, and now I need to find the numerator. What will the numerator be once we find the common denominator? That will be, well, 3x minus 2 is missing a 5x times 6x plus 1. So 5x times 5x times 6x plus 1. So that's the missing part of the whole denominator right here. Next, we're going to have minus 1 times what's missing in this denominator. Well, that is 3x minus 2. What we can do now is expand this out. And we get 150x cubed plus 25x, and in the second section we will have negative 3x minus 2. Expanding everything, you get 150x cubed plus 25x squared minus 3x plus 2 with the denominator. And this is the simplified expression. All right. Hopefully, this is giving you some idea how to approach these type of questions. I know they're tough. Moving forwards. Another example. Okay, we're going to stop here. We're actually not going to look at this example. This example is usually used in physics. I can show it to you. And what this does is it talks about how we can use a rational expression.